Hi, my name is Faisal Kasim, and this is Physics 2212 Lab 1 Charge Tapes Revisited, or rather Lab 2, and we just went over what we did from Lab 1 with a much better code. On this slide, you can see the objective of this lab, which was to model two charge tapes as point charges, calculate both the electrostatic and gravitational forces acting on them, visualize these forces with arrows, and estimate the charge required to make one tape float above the other. As you can see, we used tape, ruler, and the VPython was used for the model. And this is a quick preview of the results we have at the end of the lab. So we find out that the tapes are positively charged, and the charge on each piece of tape was calculated to be 4.3 times 10 to the negative 9 coulombs. And each piece of tape was deficient of approximately 2.7 times 10 to the power of 10 electrons. These were the initial assumptions we had before the lab. We said that both charges were and both tapes were equal charges, and every other force like air resistance was neglected. And each piece of tape was treated as a point charge to observe the forces. Here's a simple free body diagram of the system and surroundings. So we have the system, which is the rectangle and with the arrows as tape B, and the surroundings, which is the arrows points like the force, the electrostatic force from tape A pushing it up to make it float, and the force of gravity from Earth pulling it down. Before we started the lab, we took measurement of everything, and the length of the tape we used was 0.2 meters. The mass of the tape was 0.0002 kilograms. And after getting to the point of measuring the distance while floating, the distance I got was 0.0091 meters. This is how we did the experiment. I don't really have a picture of it, but this was step-by-step process. We prepared U tapes by peeling strips and then placing tape on the table and placing another tape on the table and then pulling it off really fast so it became charged. And then we observed the interaction with with neutral and charged objects to determine what charge was on the tape. By using this, I put a pen in my hair to make it negatively charged, and then I put that pen next to the tape. So if it repelled, then it means that the tape was negatively charged, but if it attracted, that means that the tape is positive. Then after that, we put two tapes, one on a stand and the other one we carried it under it with both charge sides facing each other to determine whether or not they were gonna like repel or attract, see if they had the same charges. And then we determined the distance between both of them at the moment right before it started floating. This is a picture of what I'm referring to. And this is my simple VPython code. I don't know if it's very visible, but we have the constants up here, coulombs, constant, gravity, the mass, the charge of both, and the distance. And then we created two spheres, one blue and one red. The blue one is tape B, and the red one is tape A. And the orange arrow is meant to depict the force from tape A, and green is for gravity. And you can see these are the differences and similarities between the data and the model. And these are some of the sources of error. Approximating tapes as point charges, obviously that isn't exactly exact, but we just did it to show, to help us in this lab. And obviously the two tapes won't have both charges because some of them might have been lost to our hands and everything. And surfaces might not be extremely clean. There are other environmental effects. And what if the charge is doubled? If the charge is doubled, then the force would increase fourfold. On the other hand, if the separation is increased, the force would decrease with the square of the distance. And that is all. Thank you.